Hi everyone, this is MathsForUni, and this is Lecture 1, Question 8 from our worksheet with the worked solution. The question says, prove or disprove that all of the numbers of the form n squared plus n plus 11, where n is prime, are themselves prime. So first we're asked to prove or disprove this statement, and so it's worth figuring out at some point whether we believe it to be true or false. And then we have all of the numbers of the form n squared plus n plus 11, where n is itself prime. And we're asked to consider whether these numbers, when n is prime, are themselves prime. So let's begin by putting in a few numbers that are prime for n and looking at the result. So first, let's say we take n equals 2. So we have 2 squared plus 2 plus 11, 4 plus 2 plus 11, which is 17, and this is indeed a prime number. So this is some evidence in support of the above claim. Next, let's continue looking at n equals 3. So we have 3 squared plus 3 plus 11, 9 plus 3 plus 11, which is 23. And indeed, this is also prime. If we continue on one more, we have n equals 5, the next prime number. So we have 5 squared plus 5 plus 11, 25 plus 5 plus 11, which is 41. Again, this is also prime. And so all of these provide evidence in support of the above conjecture, but it does turn out that this conjecture is in fact false. So let's see why that is. All we need to find is one value of n such that the above statement is not true. And we need n to be prime in order to be part of that statement. And so, looking at our expression, we have n squared plus n plus 11. And notice, if we take n equals 11 itself, which is prime, then we have 11 squared plus 11 plus 11. And we notice that we can factor out 11 from the whole thing. So we have 11 times 11 plus 1 plus 1, which is 11 times 13. This shows that the result is in fact not prime, because it has two non-trivial factors. Normally, to be prime, we want the factors to be 1 and itself. But here we have 1 itself and 11 and 13. Therefore, this number is certainly not prime, and therefore n equals 11 is a counterexample to the above conjecture. So, therefore, we have disproven the conjecture, and so it is not the case that all numbers of the form n squared plus n plus 11, where n is prime, are themselves prime. Now it's worth thinking about why n equals 11 was a good counterexample to even consider in the first place. Indeed, if we had continued with our above approach, having n equals 2, 3, 5, and then we have 7, the next prime, and then 11, we would have gotten there by that approach. However, we could have jumped straight to n equals 11 because we should be able to see that immediately we would have this kind of factorization. And this is what we were looking for in order to disprove this statement, because we needed n squared plus n plus 11 to not be prime where n was prime. And so by kind of artificially putting in a number that we know would give a common factor of, in this case, 11, we know that this statement would be false for that value. Of course, it wasn't immediately clear at the beginning whether in fact this statement was true or false. We put in some values and they all worked, but all we need is one value for it to fail and the overall statement will be false. If you found this content useful, then please consider liking and subscribing, and also checking out our full Udemy course in the description to get access to the worksheets for each of these videos, including this question. Thanks for watching, and goodbye for now.